Okay.
Is there audible?
now recorded.
Okay. Okay. Now, in this video, you are going to see about the forward and reverse kinematics for 3 degrees of freedom. Okay. First, I will tell you what is meant by 3 degrees of freedom. If you're having the 3 links, then this link can rotate in 3 independent directions. Okay. It is link 1, link 2, and link 3. These 3 links can travel in these 3 independent directions. So in the coordinates. So in this, so in this Cartesian coordinates. Okay. So this is our joint, we know. So it is a joint. So it is joint 1, joint 2, joint 3. And this is our final portion. It is called as end effector. If you are going to calculate this end effector E of x comma y, E of x comma y, it is our final portion, or it is our final position of this end effector. It is E of x comma y. Okay. So now we have a 2 components. It is as usual. You are going to find this E of x comma y. Then this theta 1 and theta 2 is known means. So it is similar to the previous case, right? Please, right? We have this, right? So we have this joint space and this wall space. If you know the value of theta 1, theta 2, and theta 3, then you have to find the value of length. It means it's x, y, and pi means. Then if you know the value of theta 1, if you know the value of, right? Yeah, this theta 1, theta 2, theta 3. For 3 degrees of freedom, you're having 3 angle, no? You're having theta 1, theta 2, theta 3. So it is your joint space. We have this joint space. And for world space, it is our joint space. If you're having this world space, then say what is my world space? It is for your end effector. Okay, for this world space, I will erase it, it's world space. World space, right? You have to find the value of x, y, okay, and also pi. Okay, no issues, pi. Okay, now we know the value of theta 1, theta 2, theta 3. Then you have to find the value of x, y, and pi means then it is coming under forward kinematics. If you know the value of x, y, pi, then you have to find the value of theta 1 and theta 2, theta 3 is called as reverse kinematics. This reverse kinematics is often called as inverse kinematics. Okay, so these are the basic parameters we are going to consider to solve this forward and this inverse kinematics for 3 degrees of freedom. Okay, so here you're having link 1, link 2, and link 3 here. And here in this picture, you're having the basic plane. So this is our basic horizontal plane, or this is our reference plane we took. And next is, so it's our theta 1, theta 2, and theta 3 for these 3 links respectively. And the length link is L1, L2, and L3 respectively. Here we're having L1 for this link. L1 is for the link 1, and this L2 for link 2, and this L3 for link 3. So we know this link parameter already. Then next is 1, 2, 3. We know this. Then this theta 1, theta 2, theta 3 is also known. Then the summation of this all the angles. See, I mean this theta 1, theta 2, and theta 3. Then you can get pi value. So this is also we known. If you can understand the 2 degrees of freedom, then this is very, very easy because we are adding only one extra link. That's all. Okay. So in this picture, you can see the link for the link L1, you can find this x, right? X, we know the value of x. This x is related to its adjacent side. So here we can say it as L1 cos theta 1. So it is the link length. It is for x for the link 1. Similarly, for link 2, we can say for link 2, you can say it is L2. So it is the length of the link 2 into cos theta 1 plus theta 2, because we are going to add the 2 angles. It is theta 1 plus theta 2. Okay. Similarly, for link 3, it is L3 cos theta 1 plus theta 2 plus theta 3. This is for link 3. Okay. Students, can you able to follow? Shall I continue? Shall I continue? Okay. Okay. Then this is a link 1, link 2, link 3. No. Here you have to add this total 3 link length. We're having this cos theta. So here we're having this cos theta 1, theta 2, theta 3 and all. So here we have to add this all lengths. Okay, then you can find the total length. So it is x. Okay. Similarly, for this y components, you can see this y link for this link 1, link 2, link 3. No. Take this individual link 1. If you're taking this link 1, it is related to its opposite side. Right. So here you're having theta. Okay. This is the triangle. it is related to its opposite side. So it is our opposite side, no? So we can give it as, or we can say it as L1 sine theta. So it is the height of the link 1. Similarly, for link 2, you can add and see this theta 2 angle. So we'll call it as this link 2 is equal to L2 sine theta. So it is theta 1 plus theta 2. Okay, hope you can understand what I'm telling. Next is this link 3 is equal to L3 sine theta 1, theta 2, theta 3, because we have to add this all the angles from the base. So here you can get theta 1, theta 2, and theta 3. Here we have to add all the angles. This y link 3 is equal to L3 of sine theta 1, theta 2, theta 3. Okay, so this is the total height. So it is for link 3. Okay, so we have to add. See students, this y link 3 is only for this third link. To find the total height means what? It's the total height means then we have to add all the links height. So it is L sine theta 1 plus this L2 sine theta 1 plus theta 2 plus this third link. It is L3 sine theta 1 plus theta 2 plus theta 3. So you can find this x and y. X and y. Okay. We know the value of theta 1 we know, theta 2 we know, then theta 3 also we know. Also theta 1 plus theta 2 plus, yes, so here we're having theta 2 plus theta 3. Here we're having this equation, no? From this equation you can find this pi value easily. So we have completed the forward kinematics for 3 degrees of freedom. Okay, students, do you have any doubt in this? Any doubt?